Hi, in this video we're going to look at the problem of 12 brothers and friends who have gone to a country dance where groups of 4 dancers join together in a circle, and with all of them dancing, the question is, how many ways could they do this? And so the first question we have is, what kind of notation will I want to use? Will I want to use the square brackets, which I did in the selecting the class officers problem? A, B, E, G, selecting 4 officers, or is it more like the hat problem, where A, using curly brackets, A, B, E, and G? This problem is more like which situation? Curly brackets or square brackets? So please pause the video and think that one through. So it's more like the curly brackets. And why is that? Because A is holding B's hand. And then B is holding E's hand. And then E is holding G's hand, and the crux is G is holding A's hand. And that cycle is exactly the situation we described in the hat problem. This is a case where we have 4 cycles. So now that we know that we have 4 cycles in this problem, please pause the video and make further progress on solving this problem. Okay, so we have 3 4 cycles. We have an A, B, C, D. Well, the second 4 dancers E, F, G, H, and I'm just listing one possibility for the 12. There's so many. And finally, there'll be the 4 group of dancers, which I've decided to choose from: I, J, K, and L. And let's just count the number of ways of doing this. Any one of the 12 brothers and friends could be in the A position. Then there's 11 remaining. Any of the 11 remaining could be in the second position. 10 times 9, so that takes care of 4 brothers and friends. And so then in the second group, we're going to have just 8 times 8 brothers and friends. That brings us down to 7 times 6 times 5. And finally, the remaining 4, any of the 4 can be in the first position, times 3, in the second position times 2, and then the last person has to be the same person. So right now, we have a very big number, which is, by the way, called 12 factorial. But we will have overcounted. And try to figure out one way that we have overcounted. Okay, so one way that we've overcounted is that A, B, C, D is one of the dance teams. A is holding B's hand, B is holding C's hand, D is holding A is holding B, B is holding C. That is exactly the same team as B is holding C, C is holding D, D is holding A. These are just 2 different ways of writing exactly the same dance team. And so we could have any one of the initial 4 letters as the first position, and as long as I use the same sequence, I'll have described the same dance team. So with that in mind, we see that one way that we've overcounted is that we need to divide the first group by 4. There are 4 different ways of having that 4 cycle, A, B, C, D, that are just the same. The second group, there's a 4. And in the third group, I, J, K, L, there are 4 different ways I can write those 4 letters in that same sequence, forming the same team in the same circle. There is a second way that we've overcounted. So pause the video and see if you can come up with a second way that we've overcounted. Okay, so the second way that we've overcounted is consider this group. That I put E here, F, G, and H. Then I put A, B, C, and D, and I, J, K, and L. So that's a different way of writing the letters, but it's the same 3 groups of teams. One group is the EFGH group, one is the ABCD group, one is the IJKL group. And so how many different ways are there that putting them in like this? And pause the video and see what you can come with the second way that we have overcounted. So we have a first position. We have a first position, a second position, and a third position, but they don't really matter who's in the first, second, or third. How many different ways can we overcount it? There are 3 different groupings here. Any of the 3 could have been in the first position. That leaves 2 left over. Any of the remaining 2 could be in the second position. That last one is here. And so we have overcounted by 3 times 2 times 1. So the first type of overcounting was the 4 cubed term. And now we have a second overcounting of a 6. And so the final answer is 12 factorial, which is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 4 factorial, now 4 cubed times 6. And this is an interesting problem because it uses both ideas of permutations. We were using permutations in the first part. And in the second part of the problem, in their overcounting, we looked at combinations. So when you're solving problems like these, the problems are not just, this is a permutation problem, this is a combination problem. You're going to have to sometimes use both cases, and we'll practice this in the lab.